Okay, follow along here, guys. So for question number 1, okay, we have a discus thrower spinning in a circle. The radius of that throw is 1.6 meters. Okay, we know the maximum force her arm can exert is 2,200 newtons. We're looking for how long it'll take her to complete one spin, which means we're looking for what? The period of her motion. All right, so we know the centripetal force is 2,200 newtons. Okay, we know the radius of her spin is 1.6 meters, and we know the mass of the discus is 1.75 kilograms. Okay, so there's 2 ways to go about this. First off, give them 1 mark for givens. Okay, I would say most people probably solved this in 2 steps. They went Fc equals mv squared over r and solved for v, and then plug that in to the period and speed equation, which is what I'll show you, and that's the way I have the mark set up, but I will show you the shorter way here in just a second. All right, so we're going to manipulate for v. So first off, give them a mark for that formula. Okay, manipulated for v, we're looking at the square root of Fc times r divided by m, which will be the square root of 2,200 newtons times 1.6 meters divided by 1.75 kilograms. So give them a mark for that. Okay, and we're going to get the speed here. So square root of 2,200 times 1.6. Okay, I'm shorter bracket here. All right, divided by 1.75. All right, so we're looking at a speed here of 44.84 meters per second. Okay, then we're going to use v equals 2 pi r over t, and we're going to solve for t. All right, so that'll be, so what are we up to? 3 marks here. So give them a mark for this, a mark for it manipulated for t, so 2 pi r over v, okay, which will be 2 times pi times 1.6 divided by 44.84. Okay, that's their 5th mark, and then we'll get the period here. So okay, so we're looking at a period of 0.22 seconds, because I think we only have 2 significant figures in this question. Yeah. So that would be their 6th and final mark. Okay. The shorter way is to do this. I have Fc equals mv squared over r, and I know that the formula for v contains period, which is what I'm looking for. So I substitute this formula in for v, and then I can do this more quickly, like in 1 step, right? So I square that whole formula, so it'll be 4 pi squared r squared divided by t squared. Okay, so I'm going to have Fc equals m times now 4 pi squared times r squared over t squared times r. Okay, so there's an r on the top and an r on the bottom, so I still have 1 r on the top because the squared is gone, and now I manipulate for t. Okay, so t will be the square root of m 4 pi squared times r over Fc. Okay, we've got to be able to substitute numbers or formulas into other formulas. When we get to the satellite motion part of this unit, there will be questions where you will have to substitute in order to solve, because I won't give you enough information to do it in 2 steps. All right, so being able to substitute a formula into another formula is going to be an important skill going forwards. Okay, any other questions on number 1? Okay. So question number 2, we have this freak snowstorm and a bank curve with a radius of 85 meters. So first off, we have theta, 18 degrees. We have a radius of 85 meters. It's covered with frictionless ice. Car approaches at a speed of 19 meters per second. So 1 mark for givens. All right, so what we want to find out is, will the car stay in the curve, fall into the curve, or slide out of the curve? Okay, and we need to show the math of our answer. So what should I do here in order to get this done? Like, they gave me all the parts of the equation. What do I solve for? Yeah, exactly. I don't use this number, not in my calculations. I use it only as a comparison. I want to find what the maximum speed for this bank curve is, right? And then compare it to this number. So I have the tan of theta equals v squared over r times g. So you can give them a mark for that. And we're going to solve for v. So that'll be the square root of the tan of theta, theta times rg. That'll equal v. Okay, so that's going to be the tan of 18 degrees times r, which was 85, times 9.81. Okay, so give them a mark for this, and for what v comes out to. All right. Do they stay in the curve, slide out of the curve, or slide into the curve? They slide out of the curve. They took it too fast. Okay, so we would get here that v would be 16.46 meters per second. You can give them a mark for that. Okay, that's their fourth mark. And then their fifth mark is slide out, because that's what the question asked. Did they slide out, slide in, or actually negotiate the curve successfully? Okay, which is also why I have this sentence on the answer. Because if somebody had no idea how to do this, they had a 50-50 chance of guessing slide out or slide in. So I said you had to actually show the math. You could get 1 mark for being a good guesser, but you had to show the math for everything else. Okay. All right, so the whole quiz is out of 11. So please give them a mark out of 11. Let them see it, and then I'll have you hand them in to me directly.